Hi everybody, it is February 7th and I am posting a video that you guys asked for about current supplies in 285. This is my cat, if you have never met him. He's Sawyer, he's around all the time. So, this is actually material that I wish we taught in 101. So I'm gonna call this 101. I don't know if it's gonna work here. Oh, it's not showing, is it? 101. So we always see in circuits, maybe in physics in 101, voltage supplies. I'm assuming you have a lot of experience with these two kinds of symbols. So this is a traditional voltage supply. You write something like 10 volts or minus 10 volts. And this is the traditional symbol for a battery. The only thing people in 285 sometimes ask is, if I say 3 volts, is it 6 volts? Because there are two drawings of batteries here. No, and the answer is it's 3 volts between the negative and the positive side. That's it. It's 3 volts. This here is a dependent power supply, and it's either voltage or current controlled, but it's a voltage supply still. When you see that diamond there, this is a current supply. It's also dependent supply. That means it's going to be dependent on a current or voltage elsewhere in the circuit. This here is a current supply. So these two are like brother and sister, siblings. We're going to see very soon in 285 that any circuit that has a current supply in parallel with a resistor can be equivalent to a voltage supply in series with a resistor. So these two can be actually transformed from one to the other with Ohm's law. But for now, let me just quickly go through what happens with voltage supplies in series. Basically, they add up, and very similar to resistors. And if you have a series circuit, so this is only nodes A and B, that means there's another circuit to the right of here that I am not drawing, but I want to have an equivalent circuit to this. The equivalent circuit to that will be a resistor in series with a power supply, a voltage supply. And this is A and this is B, so the two nodes stay the same. The resistors, you already know that you sum them, so 4 plus 3 is 7, plus 7 is 14, so it's 14 kilo ohms, going to be between A and B. And then the voltages add up also, except that depends on how I'm gonna draw this. It's gonna define how I add them up. So let's say I want the positive on the top side here, which is exactly how the 3 volts are. So if 3 were the only thing that I was writing here, 3 volts would be the answer if that was the only 3 volts. Everybody else, I'm going to either add to the 3 volts or subtract. And the catch is, if they are in the same direction, so the plus is on top, and this guy is not, this guy is not, this guy is. So you see how the plus is on top? That means aligned with the 3. If it is, I'm going to copy the same voltage here. If it is not aligned, I'm going to switch the sign and then copy. So this 4 is not aligned, so I'm going to call that minus 4. This minus 2 is not aligned, so I'm going to call this plus 2. So it's 3 minus 9, 5 minus 9 is minus 4 volts. So the answer here is minus 4 volts. This is the equivalent voltage to all these 4 combined. If I had wanted to draw, if I had instead drawn the minus on top, please do the math on your own. Hopefully you're going to find that it's 4 volts and it's still 14 kilo ohms. In the next video, I'm going to talk about current supplies because now I feel like it's been a long time. I don't know why.